Hey everybody, okay, this is tutorial number 2, and this one is specifically for you folks that were absent last week. If you were involved in the play, you missed out on a few of these lessons. You may have seen them and you may not have. This could be a good review for you if you wanted to just kind of go over it again, but this was the big introduction to taxonomy, to classification and how things are organized in the hierarchical categories inspired by Carolus Linnaeus, the top-down approach, the kingdom, phylum, class, order, family, genus, species, all the way down that pyramid scheme that we showed you before. Remember, there is domains. There are 3 domains that we can talk about later, but let's hone in specifically on this chart right here that you see. We can come back to this one, but this was the one that we went over in class this past week. So for the sake of review for people who've already seen it, I'll introduce it using a different one. And you can actually find these charts all over the internet. There is one in the online textbook for both honors and grade level. So if you're an honors kid, you can actually access both of them. But the idea here is that we're looking at this organizational structure. There's 7 categories, starting with kingdom being the broadest. The idea is that every living thing on planet Earth can fit into one of 6 kingdoms. Remember, there used to be 5. Let me do my hands. There used to be 5, and Monera was the thumb, this 5th one. And Monera was eliminated when we discovered Archaebacteria. Archaebacteria comes from ancient bacteria. We found them at the bottom of the Pacific Ocean, but turns out they're all over the place. They're sort of an extremophile, at least that's what we thought originally, which means that they existed in extreme climates, like super hot temperatures, for instance, around hot springs and geysers. But in any event, Archaebacteria turned out to be a unique enough organism that we made it its own kingdom. We actually made it its own domain, made its own kingdom, and made Monera. We turned that into Eubacteria. So in other words, we got rid of Monera, we added Eubacteria and added Archaebacteria. So now we actually have 6, if you count them here, 6 kingdoms. My thumb's here trying to, I suppose if I did it if I did it this way, it would make the most sense. 6 kingdoms, and you're either a single-celled organism, which would mean your Archaebacteria, your Eubacteria, or your kingdom Protista, or you're a plant, you're a fungus, or you're an animal. And if you look over here at this chart, we're dealing with animals. And so you've got a whole collection of animals, everything from what appears to be some clams, a jellyfish, a spider, some coral, a lionfish, an alligator, a skunk, a mole, koala, some sort of cat, a fox, bear, rabbit, wolves, bats, birds, etc. There's even a butterfly and a crustacean there. So these are all animals, and we know they're animals because they're not plants, fungi, or single-celled organisms. That's a very broad categorization. So now what this chart has done is it has removed some things. So what do we see that has been removed? We've removed the spider, we've removed the coral, we've removed the clam, the jellyfish, I don't suppose, the crustacean's gone, and the what do you call it? The butterfly's gone. And so what you've left behind is a group called the chordates. It's phylum Chordata. And phylum Chordata indicates or is a descriptor for all animals that have an internal skeleton that is a backbone. So all of these structures, all of these creatures, excuse me, have an internal skeleton or an endoskeleton, and they have a backbone. Notice they've removed things like the jellyfish or the clam or the arthropod, which is the spider, and the insect, which is the butterfly and the crustacean. Those have exoskeletons or no skeleton at all. And so they've been removed. So they're not chordates, they're in a different phylum. So now we have these left over. Okay, so we break it down another step. And now we've removed the shark, we've removed we've removed a fish, we've removed a reptile, another fish over here, and so what we have left are mammals. Now mammals are classified typically as having fur, absolutely, that's typical for them, although there's exceptions to that. Mainly, though, we look at the fact that they're warm-blooded. They do have some internal structures like in their ears that make them there's specific bones that are in only mammalian ears, but that's not the big thing. The big thing that we look at when we look at mammals are the fact that they're warm-blooded, they give birth to live young, and here's the huge key: they can produce milk, the mothers can, and feed their young. That is unique to all of these structures right here. I'm sorry, all of these animals right here. They all do those things. Now you might think, okay, well, I don't understand. A dolphin doesn't have fur. Well, I mean, they have some hairs. They don't require it from an evolutionary standpoint like other animals do because of climate issues and the fact that they want to be sleek and swim through the water. And then a platypus, which most scientists regard as a mammal, lays eggs. Those are exceptions to the rule. So now we bump down to order Carnivora. So again, what are we doing? We're removing the koala, the porpoise, the dolphin. We've removed the mole. We've removed the hare, the bat, and what do we have left are all of these structures. And as I'm looking at this, I'm noticing an error, because in the one that we talked about last week, we noted that this skunk actually should be right here, because a skunk is a carnivore. Now, carnivores you probably think of, or in this case, order Carnivora, as you think, well, they're meat eaters. And while that can be the case a lot of the time, and actually, if I could look up skull of skunk, you can take a look at a picture. Just look at the images of the skull of a skunk, and what you'll immediately notice is that they have these incisors, these teeth. And carnivores are primarily classified less by how they eat and more about how their skulls are structured. I mean, there are some behavioral specific characteristics to them, but in this case, a bear, a wolf, a panda, a skunk, a raccoon, and a possum, all of these creatures are considered carnivores, but they're not. They're actually omnivoric in their actual habits. But you can see these teeth are designed for tearing flesh, shearing flesh and tendon from bone, not for chewing. And that's specific to a carnivore. So that's why a skunk is actually classified with these guys. And the same thing with a wolf. In fact, we've talked about it. If I look at all these creatures right here, none of these are primarily meat eaters. They just aren't. But they're carnivores because they're classified from an evolutionary historical standpoint as carnivores. In other words, at some point in their history, they changed and they started eating more than just meat because they had to. Family Canidae. So now we remove the bear, this cat, although the cat would have, I didn't notice that before, this cat would be probably exclusively a carnivore. I can't really tell what the heck the thing is, but whatever, it doesn't matter. Point is, we've removed all of these because now we're in Family Canidae. Now, Family Canidae is all kind of dog-like creatures that we know of. So that would include foxes and jackals, wild dogs, dingoes, that kind of thing. When we go into the genus Canis, we've removed the jackal, the fox, the dingo, and now we just have coyotes, dogs, and wolves. And then if we go down to the species Canis lupus, and again, this is the part where when we go into classification, you got to be careful. Technically, the species is just lupus, but a lot of times you'll see species listed both Canis lupus. See, that's the genus. Okay, the species name or the binomial name is Canis lupus, which means it's the genus and species put together. Technically, the species is just lupus, the smallest of the categorizations, because you've got broadest is kingdom, smallest is species, top-down approach. He is an animal that is part of the dog-like group, part of the dog-like group that includes things like jackals and foxes, part of the group considered carnivores, part of the class of animals that are mammals, mammalian, meaning they have warm blood and nurse their young. They are a backboned creature, an endoskeleton, and they are a multicellular heterotrophic being that moves around, has a digestive system. They are animals. So in the end, you go all the way down to Canis lupus, which is the species. So that is the quick tutorial on how taxonomy basically works. And again, this is all inspired by Carolus Linnaeus. He was the guy that, despite it being a century and a half prior to Darwin, was intuitive enough to figure out that animals should be classified in a much more complex way than what Aristotle did 2,000 years ago. in that you aren't just going to put them in a group because they swim, because they fly, and because they walk on land. If anything, what we want to do is we want to organize them more about how they, well, it's sometimes how they behave, but largely how they have shared evolutionary characteristics to other animals, and how they're related. It makes more sense that way when you want to study them. So there you go. Of course, as always, I will say this at the end of every video. If you have additional questions, come see me at any time. Thank you for watching.